Hello and welcome to the channel. If you're new, drop a like, leave a comment, subscribe if you're new. If you haven't already, you know what to do. And without further ado, let's get into the topic of today's video, which is how to write repeating decimals as rational fractions. So let's look at an example. I feel that's the easiest way to explain it. So say for example you are given a problem like this, or no, say that you are asked to write 0.3333 never ending as a rational fraction, right? How would you do that? Well, the first thing you'd have to do is you'd have to set that repeating decimal equal to x. So we would say x is equal to 0.333 never ending, which is probably the example you did in class as well. But I really want you guys to understand this intuitively. So, how can I get rid of this portion of the decimal, which is basically the decimal? How can I get rid of it? And that is the goal when trying to write repeating decimals as rational fractions, is we have to get rid of that decimal value. So we do it through elimination because it's very simple. What do I mean by that? Well, the first thing we'd have to do is we have to multiply by 10 or 100 or 1,000, doesn't matter. In this case, you choose the smallest possible, I'd say multiple of 10, which is 10, right? So we multiply by 10 on both sides, and that would leave us with 10x is equal to 3.333 never ending, right? Now here's where the elimination step comes in, right? We have to subtract these two equations from each other. And the reason we do that is because when we subtract these two equations from each other, you'll notice that these two will cancel out. So we won't have to deal with it anymore, and therefore we eliminated it, and we can go and write this then as a rational fraction. So the process of elimination, in this case, we're not particularly worried about the sign. It doesn't really matter. So even though we know that x minus 10x would give you negative 9, it really doesn't matter. So we can just go and write it as 9x. In this case, we know that it's just the repeating 3 or 0.3 that gets eliminated, and we can go and write it then as 3. Then we just apply our equation knowledge to get x alone. We bring the 9 over, or we divide by 9 on both sides if you rather prefer that. So 1 over 9 multiplied by 1 over 9, and we would get that x is equal to 3 over 9. Very important is that you always write your fractions in its simplest form. So we can't just go and leave it as 3 over 9. We have to go and rewrite it as 1 over 3, because 3 goes into itself once, and 3 goes into 9 3 times, therefore simplest form 1 over 3. Now let's look at a bit more complicated example. So let's look at, say you're asked to write 0.12 never ending as a rational fraction. Again, we follow the exact same procedure. There's nothing special or different about this particular problem. The only thing that's different is that it doesn't have one single repeating decimal. There's two, so it's 1 2 1 2 1 2 1 2 1 2, never ending. Not to fear, the steps are exactly the same. We go and set that equal to x. And then instead of multiplying by 10, we multiply by 100, right? The reason we do that is so that we can get this value here, right, to the left side of this decimal point. Because if this remains 0, right, there's nothing really we can eliminate. And the same with the x. There's nothing really we can eliminate. So we have to do that. Intuitively, again, I'd say our goal here is to get rid of this repeating decimal. So we multiply by 100. If we multiply by 100 on both sides, we would get 12.12 never ending, right? So now we have the 1,2 never ending on both sides, which is exactly what we want, isn't it? Then we can go and eliminate. So if we go and we eliminate this equation, right, this would become 99x, and 0 minus 12, well, that would still give you 12. Pretty simple. And these repeating decimals, they subtract from each other, so they basically cancel out. And then all we have to do is apply our basic equation knowledge, write it as 12 over 99, and we have to simplify that. A quick tip for simplification, if you're not allowed to use a calculator, is that if I take a value, right, and I add the value, so 12 would be like 1 plus 2, and it adds to 3, then we know that that value, or the specific value, is divisible by 3. And the same if we take 99, 9 plus 9 is 18, which is a multiple of 3. We then know 99 is divisible by 3, but I'm just going to leave it in that form for now. But again, you have to simplify. So let's look at another example. So say, for example, we are presented with a problem like write 5.432 never ending as a rational fraction. Again, we follow the exact same procedure. We can set that value to x. X is equal to 5.432 never ending. Now, what do I have to do in this case? Well, I can imagine the 5 as still being 0, although it isn't, but the 5 isn't of much importance in this problem. The real importance is getting rid of this repeating decimal. So, again, instead of multiplying by 100, I multiply by 1,000 because he has 3 values. So we need to multiply with a value that has 3 zeros, which is 1,000. So we'd have 1,000 x is equal to 5432.432 never ending. Again, we eliminate. Once we eliminate, we would get 999x is equal to 5,432 minus 5. It's 27. So 5427, right? And then again, we're just going to apply our basic equation knowledge to say, well, x is equal to 5427 over 999. And then again, you have to go and simplify the fraction, write it in its simplest form. Otherwise, it is not the final answer. So again, I just want to reiterate this. The main goal when solving these types of problems is to isolate your repeating decimal and to get rid of it. And that's all you really have to do. And it's not that difficult. You just have to look at what you're given and just think a bit like, with what do I have to multiply? 10, 100, 1,000, 100,000, a million, whatever it is, but that will be determined by how many repeating decimals there are. That's basically it. So we're going to look at one last example, and this one might be a bit more tricky, but again, nothing too intense. So say you are asked to write 0,54123 as a rational fraction. Again, we follow the exact same procedure. We go and set that the 123 is repeating, by the way, because I forgot. We set this value equal to x, so x again is equal to 0,54123 repeating. Now, with what do I have to multiply? Right, because the trick here is that I have these two decimals, right, that are not part of the repeating decimals. But again, that's not a big problem. The only thing that means is that we have 1, 2, 3, 4, 5, so we need 5 zeros. 5 zeros in this case would be 100,000. So we multiply both sides by 100,000. This would then become 54, 123, 123, never ending. And now we have isolated the 123, sort of. Now the reason I say sort of is because what I want to reiterate is your first goal should be to isolate the 0.123, but we have done that once, right? But as you can see that we can't really get rid of that repeating decimal yet. So what we now have to do is we have to multiply by 100, which is going to equal 54, 123 repeating. And then again, the exact same procedure holds. We have to eliminate, but in this case, we don't need to eliminate here, right? So we can forget about that one because these are all equivalent, right? These are all equivalent equations because when I simplify it, it'll all revert back to 0,54123. So then again, all I have to do is I have to subtract these two, right? Because I've isolated the 123, which is all I really want to do, so that I can get rid of it. And now that I've done it, becomes quick maths. So 100,000 minus 100 becomes 90,900. Well, this should be 90,900 x, and 54 minus 124 would be 69. So 5469. And then again, we just go and apply our basic equation knowledge. Say that x is then equal to 5469 over 90,900. And again, we have to go and write it in our simplest form. We can't just leave it like that. It has to be written in its simplest form. And that is that for this video. Hope you enjoyed.